This tutorial will demonstrate how to use a new feature added in RayTK version 0.20 called variables. Start by dropping the toolkit talks into your project, and make sure to use at least version 0.20 of the toolkit. There's a link to download in the video description. Now you'll need to use one of the stable versions of Touch Designer instead of the experimental version. The version that just came out that uses Vulkan instead of OpenGL is not yet compatible with RayTK, and if you use it, the renderers won't work. Hopefully that will be fixed soon, but for now stick with one of the stable versions of Touch Designer. Open the palette using the Alt-R shortcut. Now in version 0.20, the palette shows thumbnail images for most operators to make it easier to find what you're looking for. You can also turn off the thumbnails using this toggle at the bottom if you want a more condensed view. Start by creating a RayMarch render 3D. And then create a Bezier SDF and connect that to the first input on the renderer. Add a null top to the end of the chain to see the rendered output. Now for preview purposes, I'm going to set the resolution here to 1800 by 1400, but feel free to use whatever resolution you want to use. Now on the renderer, we're going to switch off shadows, and this will improve performance since we aren't really going to need them for this scene. Now open the palette again and create a look at camera and connect it to the second input on the renderer. Set the FOV angle to 50 to get a wider view. And then add a point light. And connect it to the third input on the renderer, the light input. Set the position to 4, -2, and 5. And that is our renderer setup. So Beziers are curves that are defined by several points, and you may already be familiar with them from Illustrator or other vector graphics tools. On the Bezier SDF, I'm going to set the first point to 0, -0.4, and 0. Then set the second point to -0.9, 1.1, and 0.8. Then set the third point to -1, 0.6, and 0. Now we're going to be controlling this third point using a field, but moving it here will make it easier to see what's going on until we get to that point. So you may notice, if you try playing around with some of the positions here, that there can be combinations of positions that cause some rendering errors in here, so you'll need to keep an eye on that when you're deciding what points you want to use. And that will typically manifest as kind of like either gaps in the surface or kind of creases like that. So going back to our original shape. So in addition to the points, the Bezier SDF has radius settings that can control the thickness of the curve. The two ends have different radius settings so that you can create tapered shapes. We're going to set the first one to 0.1 and the second one to 0.01. That way it is thicker on this end and then thinner at the outer end. So in addition to the parameters to control radius, the SDF has a radius field input that you can use to control that thickness and have it vary at different points. So create a wave field and connect it to that first input, the radius field input. Now, negative values will cause the line to disappear, and you can get some interesting effects from that, but for now we're going to set the amplitude to 0.5 and the offset to 1. So that gives us values ranging from 0.5 to 1.5. Try adjusting the period and the phase of the wave, and you can change the positions here of the points just to see what it looks like. And if you change the third point's x position here, you'll notice how that wave pattern is using the x-axis, but it isn't really paying attention to the actual shape of the curve. It's just using it in space, independent of the shape. So we're going to set the period on the wave back to 0.5. Now what we want here is to control the radius based on the properties of this Bezier SDF. And this is where variables come in. Variables are similar to the iteration concept that we've covered in earlier tutorials, but are much more flexible. In later versions of the toolkit, the variables will replace iteration, but for now both are supported. Variables are a way for a downstream operator to provide its inputs with information about how those inputs are being used by this operator. In the case of Bezier SDF, it provides a variable called offset along curve, which is the position along that curve, which pays attention to where those control points are, so it will always follow the shape of the curve. You can access variables using the variable parameter page on the operator that's providing them, in this case the Bezier SDF. And each variable that's available will show up in here with a button next to it, and you can use this to create a reference to that variable. So that creates one of these variable reference operators that is attached to the source, and it shows a condensed version of the name in the image here. So in this case, norm offset or normalized offset, which means that it's scaled to a 0 to 1 range. Now, depending on the type of the variable, this will provide different kinds of values. In this case, that position is along the curve is just a single value, so this variable reference provides a float instead of a vector. If we use this as the coordinate field for the wave, instead of just using the x position in space, it's going to be using that value from the Bezier SDF as the position that the wave is based on. Now, if you play around with the phase here, you can see that it's following that, and if you adjust the points so that it shows the curve a little bit more, you'll notice how it goes along the path of the curve instead of just across it. We're going to set this back to -1. The value that's produced by the field attached to this radius input is multiplied by the parameters here. So you can see that you still get that tapering shape with the wave kind of layered on top of it. Now that we've set up our curve, we're going to make several copies of it, rotated around the z-axis. Now there are a few different ways that you can do this, and in general the best way to do that is using modulo polar. Which is much more efficient than a lot of the other options for doing this. But it has some limitations. It has a hard cutoff at the positions where it slices the angle. So you can't have the different copies overlapping each other, which we want to use in this case. Instead, we're going to use a radial clone, which makes several totally independent copies of the input shape and then combines them. Now, it's important to note that this can be costly because it repeats all of the work of the things connected to its inputs for each copy. Now, if you connect that in between the Bezier SDF and the Raymarch renderer, you'll see that you have multiple copies of it here. And I'm going to set the count to 5. You can use different counts if you want, and if you're having frame rate problems, you can try reducing that to, say, 3. Next, we're going to use the normalized index variable provided by Radial Clone to vary the point, the endpoint that's used for each of these curves, so it's different for each one. So on the variables page of the Radial Clone, you see 2 different variables here. There's the index, which is just kind of the raw number of the copy, so go 0, 1, 2, 3, so on. There's also normalized index, which takes that and scales it to a 0 to 1 range, regardless of how many copies you have. And that's the one that we're going to be using. So we've now got another variable reference operator, this one connected to the Radial Clone, and showing this norm index or normalized index. We're going to create another wave field and connect it to this other variable reference. So we're going to be using this value to control the third point on that curve. If you try connecting this wave field directly to the 0.3 field input on the Bezier curve, you're going to see an error. And that's because this wave field and the variable reference are only providing a single value, and this point needs to be defined with x, y, and z, so it needs a vector. There are several ways to do that conversion. One of them is to use this float to vector. In this case, we're going to use rescale field. Rescale field is used to adjust value ranges, but it also has the ability now to expand a single value into a vector. So if you change the return type setting here from auto, which just uses whatever the input is, to vector, it will produce a vector that has a copy of that single value for each of the components. If you connect that to the input here, you now see some variation in those points. But the range that it's putting them into is not quite what we want. So we're going to change the range that it uses for each of the axes. So for the x-axis, we're going to have the low stay at 0, and for the high, we're going to set that to negative 0.4. And for the y-axis, we're going to change the low to 0.2 and the high to 0.5. And for z, we're going to change the low to 2 and the high to 1.4. Now, the fourth part of the vector is not used, so we can just leave that as it is. If you try adjusting the phase pattern on this wave, you'll see the pattern of movement of those points within those ranges is kind of moving around the copies from one to the next, and that's because it's using that normalized index. Now that we have our scene set up, we're going to add some basic animation using expressions to give it some movement. And the first wave field that's controlling the radius, in the phase, we're going to set that with an expression at like abs time seconds times negative 0.5. So we've now got that radius wave pattern moving along each curve. Then on the other wave field here, we're going to use a similar expression for phase, but with a different multiplier, so it moves at a different speed. So abs times seconds times 0.2. So now the wave that's controlling the position of that third point is moving across the copies. And that is our scene. So to recap, we're using a Bezier SDF, which is using a variable reference from that passed through a wave to control its radius. And it uses that variable reference so that that wave pattern follows along the path of the curve. We're then making several radial copies of that, and we're using the index from that, using the normalized index variable from the radial clone, and using another wave to produce another sine wave pattern that kind of applies to each copy in turn. And we're using a rescale field with the return type set to vector to expand that single value into a vector. So we have the x, y, and z, and we're setting the different ranges for those points here. While some parts of this could be done using the old iteration system, variables allow us to use multiple levels of these values all the way up the chain from wherever they're being provided. The variable references also make it easier to see where that value is coming from, since you get that reference link from the variable reference, you get the data link to the place where it's coming from, and you get the name shown in the operator image. So lots of operators support variables, including many SDFs, as well as filters like extrude and iterated transform, and more operators will be supporting them in future versions of the toolkit. Now, there are some important caveats to keep in mind when working with variables. First, a variable reference in a network should only be used upstream of the operator that provides it. This means that there can't be a path from that reference to the renderer that doesn't pass through the provider. So if we were to create a round operator here, connect it after the radial clone, and then try to use the Bezier curve position, we're going to get an error indicator on the renderer and some strange behavior in the image. And the error is going to show something like variable source is missing in path, and then it will give you the sequence of operators from that reference to the renderer that skips over where that value is supposed to be coming from. Second, operators that provide variables may not make them available to all of their inputs. For example, because the point positions of the Bezier SDF are used to determine where the curve goes, the position along that curve can't be used to come up with those points, since it's based on those points. That means that we can use this normalized index for the radius field, but we can't use it for the point fields here. Now this is something that will not currently show a warning message, but you'll get some very strange behavior in the renderer, which is going to indicate that there is some sort of problem. Now you can maybe play with that if you like it, but in future versions of the toolkit, it's going to detect this situation and show you warnings about it. But for now, if you see strange things going on in the renderer and you're using variables, just make sure that the value that you're using and the thing you're using it for kind of makes sense logically. And yeah, this will be documented better in the future. So that's it for today. Thanks for watching. I look forward to seeing what you all create with this. And if you have any questions or suggestions, you can either leave comments here on the video or message me on Instagram or Facebook or in the RayTK channel in the Touch Designer Discord. You can check the video description for links to all of those things. And make sure to add the RayTK tag to any posts that you do so that we can see what you've been creating.